Welcome back to Outward Home Learning. The subject today is computer science, and the topic we're looking at is types of language. So that's types of programming language and types of language that the computer uses. To find out a bit more, we're going to go over to Mr. Holton, who will explain it to you.
So programming languages can fit broadly into one of two different types, either high-level language or a low-level language. And we're going to cover the difference between the two in sort of the characteristics, what features each of them has now. So let's do high level to begin with, okay? So high level languages are meant to be human readable languages. So let me give you some examples of them. We've got Python, that's one that you may have used or seen or been referred to. You've got C#, that's a common high level language as well. Visual Basic, that's a fairly common one. So all these languages, JavaScript and the like, they all have words in them, and that is a key feature of high level languages. Okay, they are human readable. The idea is that I can take some Python code and some C# and I can read parts of it at least out loud, and the reason why they're human readable is because they've got words in it, so they use actual words. Let's give some examples of this at the bottom. So for example, some Python code here. Let's do print and then we can say hello world after a little bit of syntax. So you've got like that parentheses and the speech marks after it, so you have a little bit of syntax in it, but you can see we're using the word print. That means to print to screen, and then we've got hello world, we've got what we want printed to screen. It's fairly readable by humans. Great thing about high-level languages is that they are portable between different types of computer. Now what that means is that I can take the same high-level languages, so maybe this code at the bottom here, and I can translate it to be used on different types of computer. So that could be a Mac or a PC. It's the same code that's driving it, and that could save programmers a lot of time because you're then only writing one set of code for, well, all types of computer in theory. But because we're dealing with words here, it's important to understand that the code needs to be translated into something the computer can understand, because the computer doesn't understand words, it only understands binary. So there has to be this process of translation, and the code needs to be translated into machine code before it can actually be run by a computer. So that's the basics of high-level languages, but we need to cover low-level languages as well. So here we go. Two main types of low-level languages. We're either talking about machine code itself, so that is a sequence of sort of zeros and ones, or we're talking, so when I say 0 and 1s, you're talking about binary code, or we're talking about assembly. So here is machine code here at the bottom. So 001, I'll do a byte of it, okay? And I'm going to assume you don't know what that means. I mean, to be honest, I'm not sure what it means. It may mean a number or something. I can definitely work out what the value is. But I don't know, if that was an instruction to the computer, I wouldn't know what it was. Certainly not off the top of my head. It's not human readable. It uses these things in binary instructions, okay? That is a big difference between high-level and low-level code to begin with. And it's not really meant for humans, it's meant for computers. So this is the language that computers understand. It's not high-level language, it's low-level language or machine code. And because this is the language which is understood and run by computers and processors, it's specific to a type of machine. So I cannot take the same low-level language, the same low-level code, that I'm using for a PC and just expect that to run on a Mac. The process is different. It won't work. It won't be able to understand it. Finally, if we are talking about machine code, then it doesn't need to be translated, and that saves us some time. Now, like I say, when we're talking about low-level code, we're often talking about machine code, but we could be talking about assembly. And all that assembly is that it might be like a small word like this called a mnemonic, and then some hexadecimal or some other sort of value afterwards. And all that's doing is taking sort of the first part of a binary instruction and putting a word in it to make it slightly more human readable. But still, it's when you see assembly, it's not quite easy. Well, it's really not easy to understand what's going on. But there you go. There are main differences then between high-level languages and low-level languages.
Thanks for that, Mr. Holton. So for your first task, you need to sort some statements into the correct subheadings. So now is the time to open up that document, and then you've got about 10 minutes to complete that activity. If you need a bit longer, you can pause the video and we'll review it afterwards. Off you go. And that is time up. As ever, we're going to go over to Mr. Barnes, who's going to review that activity for you. You can obviously make corrections if you've made any mistakes on that so that you've got it for your revision later on. So we're going to go over to Mr. Barnes to review the activity.
Okay, so let's have a little look at this types of language activity. Hopefully by now you will have attempted it yourself. This is just an opportunity for you to check. So, first of all, we've got the option needs translating before it can be understood by the CPU. We've got two of them, so it must go in two. Well, machine code is in binary, zeros and ones, so a computer can understand that, which means, therefore, that low-level and high-level languages need translating. Okay, next up is language is similar to the English language. Well, low level uses mnemonics such as STA, LDA, and so on. High level, or Python, is an example of high level, which is pretty much in the English language. So high level is pretty much in the English language. Language is in binary form. Well, I've already said that machine code is in binary, zeros and ones, so that's that one. Language uses a small set of command words to complete operations. Well, I just mentioned mnemonics. These are small command words that are used, such as STA, LDA, ADD, and so on. So that is low level. We've got one instruction translate to one machine code instruction. Now, low level is a much simpler, sort of simplistic type of language, although it's harder for us to use. And one instruction translate to one machine code instruction, which means high level, one instruction can translate to many machine code instructions because you can complete much more complex things using functions. So we've got code is easy to understand by humans. Well, English is our language, and if high level is similar to the English language, that will be high level. We've got each CPU has its own language, therefore code might not transfer between CPUs. Well, for that applies to low level. So these small set of command words could be different for different types of CPU. And then we've got this language can be transferred between different CPUs and work. Well, that is high level. Okay, so you can move high level language around. We've got an example of this language is Python, which again is high level. And then finally we've got CPUs can understand this language without translation. Well, machine code is in binary form, and we know computers can understand binary, therefore it does not need translating.
Thanks for that, Mr. Barnes. So finally, you've got some exam questions that we'd like you to complete on the topic. So you've got 10 minutes, give it your very best shot, off you go. Time up. So hopefully you managed to do okay with those. If not, don't worry at all, because we're going to now go over to Mr. Barnes, who's going to review those. Please make sure you mark it as you go.
Okay, so now you've learned about characters, let's have a little look at these exam questions as part of our deliberate practice. Okay, so the first question is, explain how ASCII is used to represent text in a computer system. 3 marks. So we need to sort of try to make 3 points here, really. So I'm going to start with saying that each character is given a unique number. And this number is stored in binary. I'm going to go on to say that the binary number is 7 bits for ASCII, or a byte for extended ASCII. Okay. So, before we check that one, let's go on and do the next one as well. So, state what is meant by a character set of a computer. So, very simply, a character set is all of the letters, numbers, and symbols a computer can understand. Okay, so let's have a first look at these couple of questions and look at their answers. So, right, so we've got here, so explain how ASCII is used to represent text. So I've said each character is given a unique number, so each character is given a numeric code, so there's 1 mark. And this number is stored in binary, so the third bullet point here covers that as well. I've then said the binary number is 7 bits for ASCII, or 1 byte for extended ASCII, so each character takes 1 byte. Perfect. 3 marks. The next question then is, what is a character set? So I've said a character set is all of the numbers, letters and symbols a computer can understand. So it's got all of the characters which can be recognized or represented by the computer system. So perfect, 2 marks. Right, let's have a look at the last couple of questions then. So Unicode is also used to represent text in a computer system. Explain the difference between the character sets of ASCII and Unicode. Okay, so first of all, I'm going to say Unicode has more characters than ASCII. Okay, and I'm going to then explain why. Because ASCII uses a maximum of 8 bits, which is 256 characters. Unicode can use now up to 4 bytes, which is 32 bits. Okay. And then finally, in the ASCII character set, the character codes for the first 3 capital letters are given below. So we've got A, B and C and their representation. Very simply, we need to convert the word cab into binary using the ASCII character set. So I need to represent C first, which is 0, 1, 0, 0, 0, 0, 1, 1. Then A, which is 0, 1, 0, 0, 0, 0, 0, 1. And then B, which is 0, 1, 0, 0, 0, 0, 1, 0. Okay, so let's go through these final answers then. So, for the difference between Unicode and ASCII, we've got Unicode has a much larger character set, perfect, than ASCII, 1 mark. Because Unicode uses 16 bits, well, it's up to 32, and ASCII uses 7 or 8. Well, perfect. 2 marks. And then finally, for the cab question, and this is just a checkered binary, so we've got 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0. Perfect. Full marks.
And that's everything you need to know about the different types of language used in computers and in computer science. Stay tuned and we'll see you next time.